All right, today let's take a look at section 8.2, proving triangle similarity by AA, which is angle, angle. So let's get started here and take a look at theorem 8.3, which is the angle, angle similarity theorem. We go back and we've taken a look at a similar theorem in a few chapters ago, but the idea here is this. If two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. So if you look at the two diagrams right here, you can see that if in the two triangles we have angle A is has a congruent angle to the other triangle, which is angle D, and angle E happens to be congruent to angle B. So the reason why this works out is simply, look, if we were to mark this up and say that angle A is, let's say, 60, angle B is 90, then D right here is going to be 60 degrees, and angle E will be 90 as well. And in both triangles, that third angle right here will be 30 degrees. And so in the past, we had this third angle theorem, right? If two angles of one triangle is the same as two angles of another triangle, then the third angle will be congruent as well, which happens to work out right here in angle-angle similarity theorem. So then we can go ahead and say that triangle ABC is similar to triangle DEF. So using that theorem, we are going to pretty much be able to solve the following questions in this chapter or in this section. But obviously, just using one theorem to solve things is not going to solve every single problem. There are a lot of other ways for us to find different sides and angles, and we'll work through that coming up. So let's take a look at number one. It says exercise 1 and 2 determine whether the triangles are similar, and if they are, write a similarity statement. So as I take a look right here, we have in both triangles, angle A and angle E, there's one set of angles that are congruent. That happens to both be 90, right? Now here's the kicker. If we look at the two triangles, angle B is 15 and angle D is 75. But let's pay close attention right here. Can I find angle F? You sure can, because we know 2 out of the 3 angles. So angle F right here actually happens to be 15 degrees. How about angle C right here? Well, we don't know what that is, but we know 2 out of the 3 angles. And using what we know about the sum of the angles of a triangle equaling 75, we could determine that angle C happens to be, or sorry, equals to 180. Angle C happens to equal to 75 degrees. So, we want to kind of try to prove this and put all our information together. But we could go ahead and say that angle A, right, is congruent to angle E. And angle B is congruent to angle F. Okay? So we have both of those together. And then so we can go ahead and come up with our similarity statement, that triangle. Now make sure when you guys write this out, the letters correspond with the angles, the corresponding angles. So go ahead and say triangle ABC. We use the similarity symbol, which is that little squiggly line, and then it is similar to triangle DEF. And the reason that we could use is by the angle-angle similarity theorem. And there we go. We now put together number 1. Let's take a look at number 2. All right. So we got a few angles here that we could try to figure out. Angle E we can find right here. That happens to be 180 minus 44 minus 30, and then that gets us 106. So we take a look right here. I'm looking at angle E and angle B. They're not congruent. just in case, maybe the third angle is angle A, or the two angles that are congruent is angle A. And if I take a look right here, angle A, what does that equal? We take, 180 minus 116 minus 30, put that all together, and this happens to be 34. Okay, so this right here, are they similar? I'll give a big fat no, because we can say angle A is not congruent to angle D. Okay, we only have one set of congruent angles. Remember, we need two. So that doesn't work out for us right there. Okay, let's take a look next up at number 3. We want to show that the two triangles are similar. So how can we do this right here? All right, now if you look carefully, we have ourselves two triangles. So first off, let's spot the two triangles. So I'll go ahead and highlight the two triangles there, and hopefully now you see where they are. Automatically, they both share one angle, okay? And that right there happens to be angle C. So they both have angle C right there. And so that's one set of angles that they both share. Okay, so that's great. We have angle C. And in order for us to say that, we can go ahead and put like angle BCD is congruent to angle ACE. Okay, so we have one set of congruent angles. Now remember, we need two set of congruent angles. So there's another piece of information that they give us, is that if we look at AE and BD, they're parallel. And so if those are parallel lines, we could say there's two ways we can go about doing this. We could say that angle EAC is congruent to angle DBC. All right, so let's go ahead right here. Angle EAC is congruent to angle DBC. Well, why is that? If you remember, those two angles right there are corresponding angles. Had a little brain fart there. And so they're both corresponding angles, and therefore they're going to be congruent. We could also say right here that angle AEC is congruent to angle BDC. That could work as well. And same reason, they're corresponding angles. For the first one right there, we could say that reflexive property, possibly. Actually, no, they're both just the same angle right there. They both share that angle C. So now that we have two angles to be congruent, let's go ahead and put it all together. I can go ahead and say that triangle ACE is similar to triangle BCD. And then we have angle similarity. Okay, so there we have our answer for number 3. Okay, let's take a look lastly at, or at least on this page, number 4. And let's see if we could put things together right here. Once again, I see a parallelogram, so opposite sides are parallel. And a key thing, one of the key things that I could notice right here is that we've got this transversal. So I could look at it as parallel lines right here in green, cut by the transversal. Or I also have parallel lines with PS and QR cut by the transversal. So no matter how you want to slice it and dice it, we've got some angles that are congruent right here. One of them right here we could say is angle PQS is congruent to angle RSQ. Okay, so let's go ahead and say put PQS is congruent to angle RSQ, and we can justify that with alternate interior angles. Okay, so I'll go ahead and put that right there. We also can say that, let's see, let's use this color right here. I've got angles Q or RQS. That is going to be congruent to angle PQS. All right, so I'll go ahead and put angle RQS is congruent to angle PQS. And once again, we could say we have alternate interior angles. All right, so you may think, hey, man, we've been doing theorems in first semester or like proofs, and they're still here. Yep, they just don't go away. All right, we go use them all the time to help us solve our problems out. All right, so then we can go ahead. We got two angles. I can go ahead and say that triangle. Let's go ahead and say PQS is similar to triangle RSQ. And that right there, once again, we have our angle-angle similarity. All right, let's go ahead and take a look next up at number 5. We've got quite a few problems right here that take a look at the same drawing right here. We have this diagram, and we're going to base a lot of our information or get our answers just from this one diagram. Okay, so let's see what we can figure out. Now, I think some key things to realize here is that we have ourselves perpendicular lines, right? If I take a look right here, I see this line AC and line FD. They're both perpendicular to this line B to E. So by knowing that, that does tell me that I've got a few lines, that AC right here and FD, what are they? They're both parallel lines. Okay, so that's one key thing to realize from just looking at the diagram. Then from there, that could probably help us out, figure out some other things. Let's go ahead and take a look and see what else we have. I think there's a lot of other theorems that we've kind of gone over throughout the year to help us solve the rest of these problems out. So first off is angle AGB. Okay, that right there, AGB happens to be the third angle, and so we can go ahead and determine that to be 27. Okay, right? If we have right here 180 minus 90 minus 63, that is equal to angle AGB. Okay, so that's how we get that part. Next up, let's take a look at number 6. So angle EGD. EGD right there. Okay, so what can we do there? What can we figure out about angle AGD? Well, let me go ahead and erase this red line. And what if I were to draw a line from A to D and a line that goes from B to E? And I have that highlighted right there in green right now. And so there's a relationship that we should be able to see between the following angles, with angle AGB and angle DGE. Okay, so hopefully right there you can see what the relationship between those two angles happen to be. And hopefully you realize now that they are vertical angles. So angle EGD happens to be 27 degrees as well. Okay, next up, let's take a look at angle BCG. All right, so let's see. Let's do a little erase some stuff there in the middle. And I've got right here two triangles. Um, and let's see. The measure of angle BCG happens to be down at the bottom left, and that will be 63 degrees. Okay. So as we go through the triangles right here, hopefully we do realize that we do have some triangles that are not just similar, but they're also congruent to each other. And so, we by using, like, for example, like hypotenuse leg or angle side angle or side angle side, we can figure out and determine, all right, we do have some sides and we have triangles that happen to be similar here. And that'll help us lead to our answer for number 7. If we take a look next up at number 8, we have A to G. All right, so you want to figure out what is A to G. I think in order for us to help determine that, let's also determine right here that A to B happens to be 3. Okay, so based on having congruent triangles, look, A to B is 3. So one of the things that we can do right here to help us solve for A to G is use we have 2 out of the 3 sides in this triangle ABG. And so I could find what A to G is and use the Pythagorean theorem. Okay, so let's go ahead right here. Let's put things together for A to G. I want to go ahead and put 3 squared plus 6 squared is equal to A to G squared. All right, so let's go ahead and so we got 9 plus 36 is equal to A to G squared. We end up with 45 is equal to A to G squared. We'll square root both sides right here, and A to G is equal to plus or minus rad 45. And we want to always try to simplify that if we can. And then factors of 45, perfect square factors, we have 9 and 5. So we can go ahead and simplify this to 3 rad 5, or plus or minus. We really only care about the positive one, so we have ourselves 3 rad 5 right there. So we now have number 8. Okay, so let's go ahead right here. We've got 3 rad 5. All right, next up, let's take a look at number 9. We have A to B. All right, A to B right there, we determined earlier. That will be 3. If we take a look at number 10, we have F to E. Okay, so what it looks like right here is that we have these triangles that are similar also. We have angle similarity. Think about like triangle AGB and triangle DGE. Right? We've got ourselves triangles that are starting to look like they're similar. Right? We know what some of these angles are. They both have angle similarity. Okay? And the same goes with like triangles like CBG and triangle FEG. They have angles and sides that happen to be congruent. So if I take a look at F to E, we'll go ahead and say that right there happens to be 1.5. Because if F to D is 3 and then it's being bisected, okay, uh, that G to E or that segment BE, it's bisecting those angles right there. So we have ourselves two triangles. It's going bisecting and going through and bisecting that side F to D for us to end up with 1.5 right there. All right, so we have that. Let's go ahead and move on. E to D. E to D right there, that will also be 1.5 or 3 over 2. You take your pick. I think Big Ideas might have had it as 3 over 2 because we take 3 and divide it by 2. Next up, we have G to F. All right, so G to F right there. Let's see. Now, if we have ourselves two triangles that are similar right here, and I take a look at one of the sides, okay, and this is how it'll help us out as well. Think about this. Actually, to help us out with 10 and 11. All right, if we take a look at one of the sides right here, and knowing that these are supposed to be similar, okay, I'm taking a look specifically at the 6 and the 3, okay? So if you think about that right there, my scale factor, if I put it as 6 over 3, that equals 2 to 1, okay? And that's what ends up being K, all right? So whatever the length of the triangles to the left, those are 2 times the size of the triangles to the right. So if you look at go from 6 to 3, okay, we go ahead and it's half of it, all right? Or remember, if it's a reduction, if we want to treat this as a reduction, then we'll go ahead and put this as 3 over 6, and that's equal to 1/2. Okay, so I'll have that right there up at the top. So if I take half of 6, then I have 3. If I look at segment A to B, if I know that that's 3, then half of that will be 1/2. That'll help us get numbers 10 and 11. Okay, so let's do the same with G to F right here. If C to G, okay, and C to G right here happens to be 3 rad 5, well, that means G to F will be half of that because of the scale factor. And so how about we go ahead and just put 3 rad 5 divided by 2, or you could multiply it by 1/2, and you'll still get the same result right there for G to F. So we can go ahead and say that right here. Let's see what two triangles they want us to be, tell us is similar. Triangle AGC, the very big triangle, that's similar to triangle right here DGF, and that right there is our triangle similarity. So we put all these key thoughts and informations of actually what we know about each and every side using the angles and of these triangles with the help of angle-angle similarity. From there, we use the scale factors to help us actually determine the side lengths. And knowing some things about, hey, perpendicular lines, and they both share the same line, we're able to determine, hey, we got some parallel lines here with these two triangles. And was able to use like alternate interior angles to help us find some of the missing angles there. All right, let's go ahead. Last up. So at number 14 right here, it says write similarity statements for each triangle similar to EFG. So hopefully right there we could take a look at some of the different triangles that are there in the problem. And so we can go ahead and say, well, some other similarity statements, triangle EFG right there. Let's see, EFG. We can say that that is similar to triangle EDG. Will be one of them. think we could safe to say that it's also similar to triangle BAC and also BCG right here. All right, so a lot of similarity going on. Last up, we want to take a look at number 15. Okay, so there's no diagrams here. You should make a diagram for yourself. So let's start off and try to make ourselves a diagram. I think that's one easy way for that can help us out right here. So it says we have angle H. Let's put J and K. And so this is 100. We have K right here is 46. All right. And then with our other triangle, we've got P, Q, and R. And I'm going to go ahead and put right here, let's see, P is 44. Q is 46. And then we got to try to figure out what R is. Okay, so let's see. We're trying to determine if these triangles are similar. I'm looking right now at some of these angles, and they don't seem to add up. One, let's see. Let's try to figure out what angle J is. So angle J right here happens to be 34. Angle R this right here ends up being 90. So if I take a look at some of the information that's given and I'm plugging things in, I don't really see any triangles that happen. I don't see two angles that are similar right here, right? I need two angles. So what that tells me right here, is it possible for us to determine that these triangles are similar? That's a big no, right? Because we need angle similarity right here for us to determine whether two triangles are similar. So only one set of angles are congruent. We need two to be congruent. All right, so that altogether will allow us to say that they are similar triangles, but we don't have that information here, and so therefore we can go ahead and say that these two triangles are not similar. All right, guys, thank you for watching, and good luck with your homework.